Welcome back, everybody, to the Primary Science Podcast Season 3 Deep Dives. I'm your host, Tim Holford, and today we'll be moving on to Animals, Including Humans, Part 2, where we'll be getting really hands-on with senses, muscles, skeletons, and teeth. Joining us, we've got three very special guests. Number one, Paul Tyler, who's primary science teacher, consultant, and trainer. And he's actually our first ever returning Primary Science Podcast guest. He was one of the original guests back in season 1. So very happy to have him on the show. We've then got Sarah Hutson-Dean, who's a national education lead for primary science. She's formerly the head of primary science over at White Rose. And she's a curriculum specialist focused on purposeful practical work. And last but not least, we've got Brenda Hayles, who's an award-winning science educator, consultant, and author of the HEP Science Primary Curriculum, which is currently being used across schools in the UK. She's a former vice principal and head of science, and she now works nationally on curriculum design, transition, and professional development. All right, everybody, if you're ready, let's go ahead and meet the gang and talk about animals, including humans. Okay, Animals, Including Humans, Part 2, everybody. And look at this trio we have joining us today. Thank you all so much for making the time to be with us, especially we know it's such a busy time of year right now. But before we dive in, let's just get a quick look at what's been keeping all of you busy in primary science at the moment. Paul, such a treat to have you back on the show. Loved our last chat, where you shared all your practical advice about teaching primary science. And I actually can't believe it's been a whole year since we did that.
Absolutely. Can't believe it's been a year. And it's a real treat to be back. I don't often get invited back to things. So it's a privilege to be here. I've loved watching the brand grow and listening to all the different primary guests you've had. So yeah, thanks very much for having me back.
Absolute pleasure. So Paul, what projects or classroom ideas have you been sort of road testing recently that you're just super buzzing to share with us?
So I spent last academic year developing a sustainable engineering curriculum across the school, which involved lots of practical engineering skills and then exploring those through real life sustainability challenges. So we built working wind turbines with Lego gearboxes that lit up LEDs. We explored sustainable houses with cavity wall insulation and double glazing, and then measured the heat loss from them through the walls. We built solar powered cars and explored battery technology to try and make them practical. So that was fabulous. Absolutely loved it. And then a little bit of a change this year. Still kind of exploring the sustainability themes, and that's very much at the core of what I'm doing. But I've been doing a lot of outdoor education and with classes this time, and we've been really focusing on building connections with nature as the sort of start of sustainable education. So I work with about 320 children across the upper part of the school every week, and they've all adopted a tree around the school grounds, and they're studying their trees really closely. So we've been measuring and estimating our trees. I had them out last week, bending over, looking through their legs to try and measure the height of the trees. And then we were using the perspective method, using pencils to measure the height of the trees and check. We've got leaf pressing going on, and we've been doing bark rubbing. We've been doing some artwork around our trees. And the idea is that children will kind of follow their tree through its journey and throughout the year. Also been really exploring the sort of mental and physical health benefits of nature and spending time in nature. And that's been a real light bulb for lots and lots of children. On top of that, we've done biodiversity study around the school, collected samples of every plant that we have growing around the school, and we're preserving those to create a big kind of map of where all the plants are around the school. So it's been fascinating for me to really see the impact on the children over the last sort of 6 or 7 weeks since we went back to school, of just spending time in nature, just exploring, looking really deeply, being really curious about the environment around them.
That actually sounds brilliant. And I just wonder if I can be in your class, please.
Anytime you're over here.
Nice. Okay, so over to Sarah now. Welcome aboard the Primary Science Podcast train. Really, really pleased that you could join us.
Hello. So Thank you so much for inviting me on. I've honestly listened to, I think, every single episode of the podcast so far. So I'm really, really genuinely excited to be joining you on this one.
You've been right at the heart of purposeful, practical work conversations lately. I just wonder if you could tell us a little bit more about that.
Yeah, absolutely. So for me, practical work is absolutely what gives science its identity, really. When I talk with schools and with leaders, there's a real enthusiasm for making practical work more purposeful. But I think a lot of teachers are still feeling like they'd welcome more support with that embedding it consistently across their curriculum. There's an amazing research paper out by Sarah Earles, Stuart Reed, Lynn Bianchi, and Julie Jordan, and it really explores purposeful practical work in primary science. And that's been a really useful reference point for these conversations. So at the minute, I'm working on something very exciting as well. So I'm currently developing a free Leading With resource that shares best practice case studies. And the aim of this really is to give schools those really clear, concrete examples of what purposeful practical work looks like in action, and then makes it easier for teachers to bring that approach into their classrooms.
Is there any way you could give us a link for any listeners who'd like to look more into the purposeful practical work or the Leading With series?
Yeah, absolutely.
That would be great. Yeah, we'll put that in the description to this episode. Awesome. Okay, thank you so much, Sarah. And last but absolutely not least, Brenda. Hey, Brenda, it's really brilliant to have you with us and welcome to the show.
Thank you so much for having me. I'm really excited. I love the opportunity to geek out with other scientists. So yeah, I'm really happy to be here.
Absolutely. Thank you, Brenda. And, you bring quite a wealth of leadership and consultancy experience into this, wonderful world of primary science. What's really been at the front and center lately?
So much. Just a bit of a shout out to Canva on the side, who we probably know as a design platform, but are really kind of breaking into that education space. And I've been part of rolling out the science curriculum across the UK. So that's been really exciting. But I'd say recently my focus has been on implementation, a bit like what Sarah was talking about, but also transition. So really that's supporting the use of the curriculum in the classroom. But it's also meant listening to schools, seeing what works in their context and working alongside them so that the resources really fit their learners. So the HEP science curriculum, which is the curriculum that I write, has a year 6, year 7 transition unit. And schools are now using that to help children move into secondary science with a lot more confidence. And it's becoming, which is wonderful, like a full-on transition toolkit. We've got an exciting event coming up to support primary and secondary colleague discussions. So we'll have a chance to all meet together and kind of look at some of the issues that they face in primary and secondary and just try to kind of problem solve with my support. So I'm really lucky to be part of that discussion and I can't wait.
Yeah, that does sound exciting. And I want HEP, primary science. What does HEP stand for?
Haringey Education Partnership. Hello.
Okay,
yeah, it's
nice.
been wonderful to be working with them and their member schools. So HEP Science is available in over 165 schools across the UK. So it's been, probably one of the highlights of my career. And I have a primary and secondary background. I've taught everything from early years right up to access to university. So it's just been fantastic, really working alongside them and the schools.
I think, again, is there any way that you could give us some links so that if there are any listeners who are interested in having a further look, I could put that in the description for them as well?
That'd be brilliant. And I think I'll try and get some freebies as well.
Always like a freebie. Nice. Okay, well, welcome everyone to the show. So I've been trying some new games, and for this one, I've decided to see if we can do one of my old favorite game shows, Catchphrase. So what I've done is I've asked my students to get involved as well, and I gave them 5 different prompts. Each one was something to do with senses, muscles, skeletons, or teeth, and I asked them to draw it. And then, so I'm going to show it on the camera. And if you all have a little piece of paper or a mini whiteboard with you, I'll give you a few seconds to jot down what you think my prompt was. And then if you're close enough, You get the point. I think I'm going a little easy on you for the first one. Hopefully you can see it well. Okay. What do you think my prompt was that they were trying to draw to do with senses, skeletons, muscles, or teeth? Okay. Have you all got an idea? Okay. Hearing from Paul. Sarah says first thing they could hear. And Brenda, could you go a little closer to the camera there, Brenda?
Vibrations. My
Bit higher.
handwriting is terrible.
Sound waves, radio waves, vibrations.
Vibrations.
Okay, I'm going to give you all a point there. So it was when sound waves hit the eardrum and make it vibrate.
Hey.
And keep in mind as well that we haven't studied sound yet in year 4. So this student did very well. I'm very impressed. This one could be more challenging. Here we go. And viewers at home, you can try and play too. See if you can guess what my student was drawing here.
Oh, this is hardcore.
We go hard on classroom catchphrases.
Yeah.
Okay. Do you all have an answer ready? Go ahead.
Wrong.
I think I might be.
Oh.
Okay, Paul's got molars chewing up food, injured knee, synapse. Okay, those are really good guesses.
That's a
I can say there, but yeah.
That's
Wow,
why
yeah,
I put a
let's have another
question
look.
mark, because I was like, I just don't know.
Of course.
So the prompt was molars chewing and grinding food, breaking it to smaller pieces. So well done, Paul.
Well done, Paul.
2 for 2.
Well done, Paul.
There's still time to catch up. This one. Ready? I think I'll go closer on the important part. Okay. Does everybody have an answer? Okay. Let's see what you got. Bicep muscle contracting, bicep muscles pull, and muscle contracting. I'm going to be very nice. I'll give all 3 of you a point there. The exact prompt was muscles contracting and relaxing to move your body. So that was quite a good one as well, seeing as this student hasn't studied that for a good year or so as well. So that's really impressive again. Okay, number 4. Here we go. So remember, it's only to do with senses, muscles, skeletons, or teeth. Another really good drawing there as well. If you're ready, 3, 2, 1. Let's see what you got. Observing. Okay. So you're going for working scientifically. Villi, good bacteria, intestines. Okay. What they saw outside. Oh, okay. So I'm afraid nobody gets the point there.
Oh.
So the prompt here was the skin helping us to sense touch, texture, and pressure.
Oh, of course. Of course. It was good drawing.
I can see it. I can see it now.
That's a really difficult one to draw. So again, well done to my students for that, for having a go. And then the last one, if anyone gets this, I'm going to give you 10 points and you win the whole thing. Okay? So here we go. 3, 2, 1.
It's like something from an A-level biology textbook.
Yeah, it does actually. Okay. Everybody ready? Okay. If you're ready, let's give it a go. See if anybody got it. Inside of the nose. Ooh, good one. The tongue. Tongue. Okay. So I'll tell you the proper prompts and then you can decide if anybody got that. So it was taste buds on the tongue, tasting the food.
I was going to write taste buds. There
we go. Okay, I'd say 10 points there for Sarah and Brenda. There you go. You both win the show. Awesome. Thank you very much for playing, guys. You're good sports there. And thank you to my students as well for getting involved. I had loads of fun. Did you guys have loads of fun?
That
Yes.
was brilliant. Yeah.
Nice. Okay, let's get into the main discussion now. So first up, we've got year one, where it goes right back to the beginning. Children start identifying, naming, drawing, and labeling basic body parts. And then they say which parts associated with each sense. So start linking that function and structure a little bit. So this is all about anchoring that vocabulary to their lived experience. You know, the eyes see, the ears hear, the skin feels, and so on. So let's start with Paul. What go-to hook do you have that makes the senses feel really real and memorable for the kids?
I suppose the starting point is just them understanding that they have the senses and how they use them, and giving them opportunities to touch different things, to see different things, to look at things in sort of different lights, you know, turn all the lights out in the classroom and what can they see, put the lights up. I like it to be very practical. I like it to be really hands-on. I'll quite often start with some kind of sensory illusions. We can trick our senses to show children that things aren't always what they sort of see or feel or taste. And there's some really nice sensory illusions online that you can then try in class. So one of them is about the McGurk effect, and this is the idea that, you know, the sound that someone's making doesn't match with the movement of their mouth, and it's actually really good with younger children because they're just learning their sounds and they're learning their phonics and their phonemes, and it's all about that, the importance of being able to see what somebody is saying as well as hear it. And so we listen to some of those little sort of videos. I try and do some of it myself as well, which is always quite entertaining. I also play some sort of song lyrics to them, but then put up on the board or tell them what the lyrics are, and then play the song and see if they can hear what I've told them or what the lyrics actually are, and which is always good fun. And there was some brilliant little YouTube videos, really short ones aimed at young children, all about that sort of idea that if we mishear something once, it doesn't matter if we hear it again. And if we actually know what it's supposed to be, we will still mishear it. We also explore optical illusions and sort of see how our sense of sight can be tricked. And again, there's various different things. One of the ones I love to do with young children is I don't know if you've ever seen this, but did you see the gorilla selective attention test, which the wee ones love, and they're busy counting the passes, you know, and all of a sudden it comes up and there's this big gorilla in the middle of it. I'd like to explore as well the sense of taste and how it's linked to our sense of smell. So get the children to hold a mint leaf under their nose while, you know, tasting different things, or giving them orange juice with black food coloring in it so it doesn't look like orange juice. And then also things like looking at sense of touch. So getting them to, use feely bags with different things in that might not feel quite how you expect them to feel. Or looking at little tricks you can do. So there's the hot and cold water experiment, which is a brilliant one with young ones. We put a hand in hot water or kind of warm water, a hand in cold water, and then you put them both into water that's kind of between the two, and it's impossible to tell the difference because one half of your brain says it's really hot, one half of your brain says it's really cold, and so you just get really confused. And there's a really nice one which I'm not done with year one for a while, or with our nursery kids for a while, but I have done it in the past, which is the invisible string one, where you get them to hold their fingers a certain distance apart while you tell them that you're wrapping string around them, and very slowly their fingers will get closer and closer together. And it doesn't matter what they try and do, their fingers will always start moving closer and closer together. And it's just showing them that there's just these sort of neat little ways of, tricking our senses. Our senses aren't totally fallible. They're just a way of collecting, sort of information around us. So what it really lets us do is kind of discuss the five main senses, explore the idea that they can be tricked in a really nice way that children can then go home and do at home with their parents and carers at home. It also brings in the idea that our senses don't work in isolation, they work together. And this is something that we then look at later on as well. So in our Scottish curriculums, we come back to senses later on. And one of the things we look at there is how certain senses can be enhanced if other senses are impaired. And there was a fabulous documentary on the BBC a few years back now of a man who's been blind since birth but uses echolocation to navigate his way around. And he's a cyclist. He goes cycling all over the world, and uses echolocation to navigate. And it's just absolutely mind blowing. So it's powerful sort of build on messages around senses and how they work and how they work together.
What a great way to introduce the senses as not just, labels, but they're actual systems, and you can fool them, and they're feedback loops that really work. And it just keeps the kids questioning as well, makes it really real for them. So over to Sarah now. Do you have any clean and crisp ways to move beyond the typical point to your elbow kind of thing into genuinely using our senses for inquiry?
Yeah, so I think the senses are a fantastic way, really, to introduce Year 1 children to the processes of scientific inquiry. Children are naturally very curious about the human body and have a lot and can generate a lot of questions to find the answer to. I think, as you said, the first building block is to make sure they can accurately identify parts of the body and say which part of the body is associated with each sense. But then I think once they're confident with that information, I like to begin to challenge their understanding of each sense. So if we take your example of point to your elbow, we can then start to generate questions around that sense of touch. To open that up, it might be, well, where can we actually sense touch? Quite a lot of children just believe it's through the fingers or through the hands. And I think I like to then encourage children to think about, where they can actually feel it and linking it to real life as much as possible. So, where can you feel it when you're putting your coat on, or where can you sense touch as you're, cuddling the teddy bear? And at that point, I'll start to move towards generating questions for testing. And I think very much in Year 1 and throughout Key Stage 1, through that guided discussion, we might come to something like, which part of our body can feel things the best. So then once we've got a good question that we can test, we talk about how we can find that answer. So with that, I then like to think about sort of that purposeful practical, going back to that. What is it that we can actually do with the children? So I might give them a range of really familiar materials that they've come across: foil, felt, bubble wrap, plastic bags, things like this. And then I'd like to think, would any of our other senses help us work out what material that we're sensing touch here with? And it's interesting to discuss with the children how sight can influence this, and how by reducing sight, they really have to just rely on the sense of touch. So then I'd start thinking about the practical activities. So working in small groups, children can test whether they can feel the materials using their fingers, using their elbows, using their face, and so on. And then try and identify exactly what that material is. Now, depending on what the skill focus is here, they might record their answers using simple ticks or crosses in a table, whether they could feel it or they couldn't sense touch, or they could. And ask them whether it felt different with different body parts, and was it harder to identify it with different body parts? Something that I found is a really sort of great extension at the end of like a lesson like this is through discussion with the children, is to rank the body parts from easiest to identify what the material was to hardest. And again, it might be done verbally or with a simple pictorial rating scale. But by ranking the body parts, I found that children can really use their evidence and their understanding of the sense of touch to answer, the question that we've generated together.
Yeah, I liked linking it to everyday experiences with putting on the coats or hugging teddies. I can imagine that going down really well, and the children, again, relating to science and building that science capital. That's really, really good. So you mentioned there that you guide the class discussions into that testable question. And that is often the tricky bit for lots of us. And I just wonder how you steer the children towards that testable question, but still keeping it in their hands.
I agree. I completely agree. It's really tricky to find that fine balance between the two. And I think it's a key skill for the teacher, and one that took me quite a lot of years to kind of get to the point that I thought this is right, really. But it's genuinely for me about steering the class towards that testable question whilst keeping children's ideas at the centre, so they feel very much part of the process all the way through. I think for me in Year 1 and across Key Stage 1, it takes a lot of teacher modelling of this. So I'll often start with a stimulus and do a lot of thinking aloud, showing how I generate ideas, showing how I would generate questions from this stimulus. And then I encourage discussion within the classroom. So, using talk partners or in small groups, using, my modeled sentence stems and things like this before sharing their reflections back with the class. And from there, what I like to do is then record all of their questions. They're very much that skill of asking those simple questions. So everybody's ideas for me matter. We can hone it, we can refine it as we're sort of going through the lesson, but getting them on a working wall or a large shared piece of paper. I then think about shaping that discussion step by step so we arrive at a question that we can actually test. A lot of the time in the background, I am mindful of the inquiry type that, we would like to cover or I would like to cover for progression. But so I do nudge the discussion in that direction, but very sort of carefully so to not take ownership away from the children and their ideas. And I think, as they move through primary into lower and upper key stage 2, I do then shift the responsibility more onto the children. So a lot of the time there, it might be them creating their own questions and then starting to sort them into different inquiry types, just showing that clear progression and, helping them to understand that there are different ways to find the answer to a scientific question.
Yeah, that's a tricky question to answer, I know, and you did very well. That actually clears a lot of things up. So thank you very much for that. Okay, so over to Brenda. This is a question that I get a lot. They say that two of the senses that can be really tricky to teach can be sight and hearing. They can feel less hands-on than taste or touch. Have you found any sort of playful, practical routines or ideas that brings those two particular senses alive for year 1?
Yeah, I just think it's because we take this for granted so much, and the issue is that generally children we all are constantly seeing, constantly hearing. So it's trickier to kind of make them notice those senses deliberately. And you mentioned when you were talking to Paul about not really just what you're seeing and what you're hearing, but I think we can take something as simple as what you're seeing and what you're hearing, but layer on the discipline of science, and it's a completely different experience. And I was just thinking, so my daughter is now in year 2, and when we're walking to school, we'd see things, obviously, and she, they're like a sponge. She would see things all around her. But there's a difference between her noticing and just seeing things, and then developing that more into the discipline of scientific observations. So, of course, we've got that basis of eyes are for seeing, ears are for hearing. And in year 1, we're very much using their own bodies as that starting point and that gateway into science. But to really kind of give some of that discipline of science, I'd use things like a soundscape. So just play a simple clip, for example, one from the city and one from the countryside, or it could be whatever, really. And just getting children to, without seeing those scenes, just think about the sources of those different sounds and compare what they're hearing in each setting. And you've got children in the same classroom hearing the same sounds, but they will notice different things. And it's really quite interesting to see how they do that and to notice that, we kind of have that gist of a sound. It's part of our survival. We don't really focus in too much detail on the things going on around us. But if we are very focused, we start to pick out those little differences in layers of sound. So that's been really nice to see children do. I also ask children to brainstorm sounds in familiar settings and familiar places. So in the playground, at home, in the classroom. And we extend this to a listening walk. So we go on tour, could be to the local park, could be to the playground, could be around the school. What sort of sounds do they expect to hear? And how does that compare to what they actually do hear? So really simple predictions, really simple ways of gathering data based on the senses as well. In terms of sight, I use the Great Science Share. They've got a viewing window, so it's just got that transparent rectangle in the middle. It's a really simple thing, and then it's got some prompts around the window, and you can obviously change them based on what it is that you want the children to focus on. So again, children know how to see, but not necessarily how to make those focused observations. And it's a really nice way of kind of training them to look at things and notice, again, those layers, notice the colours, notice shapes, movement, structures, those sorts of things, and to really look in a more sophisticated way. And they will see things that you would not imagine. We're looking at a stone, we're both looking at a stone, but the things that they come up with are fantastic. And I always say this links back to the national curriculum. They talk about that awe and wonder, but what does that look like in the classroom? It's, I think we kind of forget that in the business of planning and assessing and all of that sort of thing. So it's really nice to create those moments where children get to really use their imagination within the confines of the discipline of science. To make it more fun, if you like, because we've got to have that playful aspect of it, you can kind of drop some objects intentionally into the space and just sort of see who picks up on it and what sort of things children say about those objects, and have a lot of fun with that. Those kind of really intended points for discussion. So you can still kind of guide that activity, even though it's an open activity. And I think even at this stage, they're not just matching body parts to the senses. They're starting to connect that structure to function, and to use their senses in the way that scientists do, just to kind of send those senses out into the world and collect data, bring it back, and we help them to make sense of it.
In a way, you're giving them the reason why we have senses. It's all very well and good learning, okay, we have these senses and this is how they work, but why do we have them? How do we use them? And yeah, it makes it real for them. I'm just wondering as well, once you've run all of these activities, do you have a way of capturing what exactly the children have noticed? Do you go for drawings or data tables or open discussions, just to maybe get some of their misconceptions or ideas that they have?
What I would say is that I think this is a really tricky area, particularly for Key Stage 1, that balance between the kind of doing and the recording. And you get a range of teachers and a range of sort of comfortability with getting children to collect data and the level or the extent to which they write down and capture this data. But I think if we just have the overall idea that in year 1, for example, what we're really aiming for is to kind of take, again, what I mentioned in terms of the noticing, take that noticing, that passive kind of walk through the world, and turn it into some more tangible things, which might be in the form of a written scaffolded worksheet, a drawing. But for me, it's very much about the language that children use, and looking at opportunities for them to develop that language and building in opportunities to use that language again and again so that they become more confident with it. I'm probably going to overlap with what Paul and Sarah have said already, but if we don't deliberately build in those opportunities for descriptive vocabulary and simple sentence stems, then what will happen is that children with the richest language are going to just keep on being able to pull from that and pull further ahead. And you'll widen the gap between the children with the strongest vocabulary and those with weaker vocabulary. It links back to a piece of research I love to mention, the Matthew effect, the idea that gap that you have between the children who have that massive vocabulary in their repertoire, they've had that exposure, they've had those turn-taking conversations, and then the children who are at a disadvantage because they haven't had that exposure to language. It's definitely our responsibility within science to look at the vocabulary that children need to be able to access and to build in as many opportunities as possible. So for me, yes, there's the drawing aspect, there's the written aspect, but certainly opportunities to practice that language. I think it's the best way to kind of narrow that gap. Otherwise, you're going to have children who are using all this description, all these adjectives, and then you'll have children who say things like, I saw a bird, I heard a sound. So we have to put a lot of thought beforehand into how we're going to support those children, as well as stretch and challenge. So I think we can have a lot of scaffolding that is verbal. It could be through simple frames for drawing and labelling. Yeah, that's a nice way to practice vocabulary. And it could be through structured talk prompts as well. And so the chat's not just open. It's more guided with opportunities for children to talk about, again, those colours, those shapes, volume, the loud, quiet sounds, high-pitched, maybe even low-pitched sounds, the different animals and the different kinds of sounds that they might make. Birds, can they recognize any of the bird song that they hear? And, with really small supports, you can turn quite a playful activity or fun moment into a real solid learning experience. So I hope I answered the question there.
Yeah, absolutely, you did. And yeah, you make a very good point there about this more dialogic focus on teaching. I think it was a recent EEF report that stated, based on research, that taking a dialogic approach is one of the most effective ways. So we move on now to the next year group, which is in year 3. They start to tackle skeletons and muscles. They start to identify that humans and other animals have skeletons and then muscles for support, protection, movement, and naming those key parts. So let's dive into that a little bit, and we'll start with Paul. I think in your experience with this, what models or mini investigations have you seen that help children see muscles moving, the bones, joints?
I always have approached it from a kind of engineering perspective. So seeing the body, seeing their bodies as a mechanism, a system. I always get the children to focus in on one particular joint to start with, at start the activity. So maybe the knee or a system of joints. So maybe the hand, and really study it closely, realizing that their own body is the best way of studying these. It's all right to have an expensive full-size skeleton, but actually their body is the best sort of toolkit they've got to explore this. So by experimenting with their own joints, which directions they can move, what makes them move, even talking about, starting to look at how they're held together, and then start to build, or get the children to build as accurate as they can, a working model of the joint or system. And I would usually do that with corrugated card because it's quite nice and strong, and then split pins to get the movement, some elastic bands for those who need stretched a little bit to be muscles, and some string. And then the really important bit is to get them to explain then to their peers how it works and what they've observed in themselves and how they've turned that into a working model.
I just wonder if you let them tinker and adapt those and play with them and maybe change them in a way, or do you just prefer to guide them towards one accurate build and then they just focus on that?
Yes, again, I suppose it depends a little bit how long you've got. I always try and use a sort of iterative process with any engineering projects that I work on, whether that's with the really younger children in the school, building with make-do kits, or with the older ones doing more precision engineering. So there's loads of tinkering at the start. There's loads of trial and error. There's lots of building models, testing them. Does it do what we actually know it needs to do or what it should do? And if not, then we refine it and rebuild it. And the brilliant thing with the corrugated cardboard and split pins is it's such a quick process. So children can get through refined iterations really quickly. And you'll find, in a lesson, children might have built 5 or 6 models of their hand, or of the elbow working, or the shoulder, or whatever it is. And with each one, they learn a little bit more. We got our shoulder to move this way, but we couldn't get it to move this way as well. And so how are we going to do that? And so they go back and they think about it again, and they come back and they'll have another go. If you've got the time, iterative engineering is such a powerful way for children to learn. That ability just to try again, take it apart, what worked, what didn't work, right? What can we improve? Try again. A lot of it comes down to the amount of time you have and the amount of time you can afford to spend on it. But as a methodology, it's really powerful to see them go through that.
And it's almost worth spending the extra time, because what's better than actively learning how something and why something is the way it is? On to Sarah now. I wonder if you could tell us a little bit about any ways that you've seen that make that trio of, support, protection, and movement clear and simple.
Yeah, I think for me, the key is making the functions of the skeleton really, really concrete for children. I've found myself when teaching this that support is often the hardest for them to understand, because it is less obvious than, say, movement or protection. So a way that I've sort of thought about and linking to real life here is I use the image of a tent. So with the poles in, the tent stands quite tall, but then without them, it collapses. So that really is that simple way of just looking at the idea of the skeleton giving us structure and making that sort of much clearer for children. Another thing that I've also thought of with support as well is comparing humans with animals that don't have that internal skeleton structure, like a jellyfish, and then starting with a question or a discussion point or prompt. What would happen then if humans didn't have that internal skeleton or internal structure? And it really just encourages children to imagine and explain and discuss the importance of support. I find that protection is usually easier because it's something tangible that they can actually sort of feel. So I might ask them to press their hands against their rib cage and notice how the bones there are protecting the organs inside. And then for movement, very much like Paul and Brenda have already said, really getting them to use their own body and understand how it's working. So getting them to bend their arm and feeling the muscle contract and notice how the bones and the joints work together to allow that motion. So once they've had all these, experiences, they've really sort of got to use their own bodies and, think about working with a partner and these sort of things. I find that a sorting activity really brings all that learning together. So I get sort of I just go into the playground and steal the hoops that are there. And I give them examples with cards on, skull, ribcage, spine, and then I label the hoops with support, protection, and movement. And as they are sorting the bones into the different hoops, they quite quickly notice that the same bone can have more than one function. So it really enforces the point that the skeleton as a whole is always supporting, protecting, and enabling movement at the same time. So I found that a nice way really of linking the three together.
Yeah, that is a very clear way of breaking it down. I'm wondering as well, when you run that sorting activity at the end and the children notice that the bones sit in more than one category, how do you use that moment? Is there a way that you open it up to wider discussion and get that dialogic approach going? Or do you maybe steer them towards a particular understanding of the skeleton working as that integrated system?
I think there's really opportunity for both. So sometimes I might be thinking about letting children take the lead and explore why bones might belong in more than one category, because that opens up that really rich discussion. I think it's that finding the moment when to interject and when to not. If you're going around and listening to conversations, if they're having these discussions already, it's about knowing whether it's the right time for me to go in and join that discussion or not, or let them come to that understanding through that, talk, through that partner work there. And then other times as well, I might steer it a little bit more directly so they see that bigger picture of the skeleton, providing support, protection, enabling movement.
Yeah, the all-important adaptive approach. Love it. Okay, thank you very much there, Sarah. And on to Brenda. So when it comes to teaching skeletons and muscles, do you have any simple investigations or classroom activities that you think really give children that aha moment about how our bodies move and work?
Yeah, I think there's that go-to investigation that Paul mentioned, with the cardboard and the butterfly pins and the elastic. I'm all about that creativity, imagination, and also repetition. So it could be something quite simple, but you can get those aha moments from it. So once you've made that model, I call it exaggeration, right? And it's a lot to do with application. So once you've made that model with the cardboard and the elastic, and you've gotten children, to a solid point where they can explain what each part represents, what it's called, what it does, then I would ask them to imagine, how would the model change if we were looking at a chimpanzee's muscles, or a bodybuilder, or even an elephant's trunk? So you've got lots of awe and wonder in terms of how an elephant's trunk works and all the muscles in that, etc., etc. But we're not just sharing that information with them to impress them. We want them to do that, that full loop where they can bring that into their learning, and things that we haven't explicitly taught them. Can they use their imagination? Can they use the basics of science that we've taught them to apply to different situations. So they will come up with the fact that perhaps a chimpanzee or a bodybuilder might need a thicker band or a longer band, those sorts of things, or a shorter band. And that's an interesting discussion to have as well. Or an elephant's trunk, we might need more elastics to show how flexible and complex that structure is. So it's about creating that safe space as well, where it's not so much about the right or wrong, it's those discussions that you have. Scientists over the ages, as they've been creating things, they haven't always been right, but they've had those discussions and bounced ideas off each other. And that's really the beauty of science, and where we get those aha moments, I think, as well. So lots of opportunities for what ifs, imagination and creativity. And at the same time, they're repeating, it's that same model, but looking at it from different perspectives and pulling as much as we can out of it.
Nice, thank you. Yeah, keeping it playful but powerful as well at the same time.
Yeah.
And I think you've in part answered my next question a little bit as well, but I'm still a bit curious. Once you've got the children playing with those exaggerations, is there a way that you tie it back to the scientific accuracy? Like, do you let that creativity run to its fullest first, and then bring them back to the real sort of biology of it? Or do you weave both together as you go more purposefully throughout?
I think, again, so for me, I always have the curriculum points in the back of my mind, and that's where the vocabulary is going to stem from. That's where the activity is going to stem from. I'm going to steer it that way, but pretend that I haven't. And I think that those exaggerations, they're not exactly the end point. It's what I would call more of a rehearsal space. So these ideas, these things that they're learning and developing, again, that safe space for them to rehearse their ideas, develop their ideas, refine them. And it gives children a lot of practice thinking about how the body moves, but talking about it in different ways, and using models to kind of show that link between structure and function, and to make it really visible. So it's very much related to the curriculum points, but we get to circle back again and again, and discuss those curriculum ideas from different perspectives. So with each new variation, whether it's a chimpanzee or a bodybuilder or an elephant, it's really just another opportunity for them to practice that precise knowledge, and to use that accurate language. So it's just about that repetition in imaginative scenarios to kind of pull in and engage, but it's really just to secure that specific curriculum knowledge.
Thank you very much. Okay, so we move on to year 4 now, where the focus sort of zooms in on teeth. We start to identify incisors, canines, molars, and their simple functions. So it's quite tactile, it's really visible, and quite a brilliant doorway into how the form fits function. So over to Paul. Do you have any hands-on demos that you love for comparing the tooth shapes, including across different animals, that sort of avoids it becoming a worksheet marathon?
Yes, again, I think hands-on. I think messy is always good when it's when you're doing teeth. So we would explore how food is chopped up in the mouth and use different tools to kind of mimic the teeth. So usually I get a big kind of clear mixing bowl at the front of the class, and they come up and take it in turns to try with different tools, and try and choose the tool that matches the tooth function. So I might use a potato masher for your molars, a sort of sharp wallpaper scraper for incisors, and then kebab sticks or knitting needles for canines, and then demonstrate or get them to come up and try and see how the different teeth work on different foods. So I would give them some bread, some cucumber slices, biscuits, chicken bits, cooked pasta, etc. I've become a little bit more food waste conscious, so I tend now to try and look for possibly a synthetic food substitute, so a bit more plasticine being used, or maybe sort of scouring sponge that can be torn apart, that sort of thing. But if I'm honest, with this topic, you can't really beat some real food in there. And then the children can, having tried that and seen which tools work best, it's then getting them to relate that back to the teeth that they have in their mouth, and also do some research on the different types of teeth that different animals have, and then maybe look at predicting the diet of those animals. So I suppose I've always been quite lucky. The schools I've taught in, we generally have quite a high proportion of children who have pets of one description or another. So usually as a homework task, it might be to get them to attempt to, with parental help, attempt to get a photograph of their pet's teeth, or something like that. I do have friends who are in veterinary science, and so I do have a collection of sort of X-rays of various different animals' teeth from the different places they've worked. But getting them to do that little bit of research and try and make those predictions about the sort of diets that certain animals might have based on the shape of their teeth.
And I think I agree. Whilst it is important to focus on sustainability, there's nothing like getting a little bit messy and making it really relevant for the kids so they can understand, well, this is food that I eat and this is how my teeth work eating these foods. So I think, to some degree, you do need to do that.
The animal teeth bit is always a bit more of a challenge. I have got a collection of animal teeth from different animals that I've sort of put together over the years from friends who are vets, or from owl pellets, which we do as a dissection. You get lots of little teeth out of that. And that's, once you've sterilized them, the children can then have a look at them properly. That really kind of just brings it back to, again, the shape. I suppose the other one, I'm just thinking back now to something I did last year at our science fair, was about getting the children to eat a grape and see what's it like if you eat a grape just using certain teeth. So, if you eat a grape with your canines, how's that different from eating it with your incisors compared to eating it with your molars? And you go from, getting a nice clean cut through to getting a sort of explosion, when you're using your molars. So that's a really nice way, again, of sort of, grounding that and showing the different functions of them in a very sort of real way.
I quite like the grape idea. With my year fours, we've tried a few different types of foods, but I hadn't thought about using one single type of food and then the different types of teeth. And we'll move on to Sarah. I wonder if you've got any assessment-friendly activity that helps the children match the tooth type to the function, whether it be cutting, tearing, grinding, or ripping, and then to be able to explain why there's that match and not just be able to label it.
Yeah, absolutely. So a great activity that I've used is actually modelling the teeth using modelling clay. So the children actually shaped and positioned the incisors, the canines, the molars, and they thought really carefully about the different sizes and their shapes. So once they were complete, we did labels. So we added cocktail sticks with little stickers on, which they found incredibly fun. That was a bit they really enjoyed, and labeled those. But then alongside that, I wanted them to write descriptions explaining the functions of each type of tooth. It showed me that, they could not only label the teeth, but that they understood how the shape links to function. And it really gave me a clear picture of who could move beyond naming and actually explaining the why. I think as well, to make it accessible for everyone within the class, some children recorded their explanations using talk buttons instead of writing. And that gave them a chance to show their understanding in their own words. And it also meant that I could gather that, that crucial evidence of spoken learning just as easily as that written evidence. And again, listening back, it made it really clear which children had grasped that shape and function link, and, which children still needed that to be taught again or needed a bit more support around that. Using that modelling idea gave me a great chance to talk about simple limitations. So, asking questions such as, do their modelled versions really capture the accuracy of teeth? Did the position and the shape of the teeth help them to choose, their function or explain their function to me as well? And with that, looking at the limitations, it really showed me who was beginning to think critically about scientific models, and very simply within year 4. It's not a skill that we're expecting them to master by any means, but it moves beyond that, just reproducing that model. I think as well, linking it back to the role of the teeth in digestion gave that really strong end point, showing that children could identify the different types of teeth, explain their simple functions, in the role of breaking down food for digestion.
Nice. Thank you very much there, Sarah. And I really liked the use of talk buttons there, because it links with what Brenda had said before about, using that dialogic approach, making sure they get as many chances as they can to use the language, to speak the language of whatever science it is they're learning. And talk buttons can be quite a simple and effective tool for that. And then you can also use it for formative assessments as well as you go. So that's really good. Thank you.
They're amazing. I absolutely love them. They've captured some
Absolutely.
fantastic things over the years.
I'll bet. I wonder if any of those things, have you found like any particular trends in misconceptions that keep popping up around tooth functions? And if so, how do you kind of tackle those while keeping the inquiry going?
I think the really common misconception that children I've taught have about teeth is that they all have the same function, and that function is chewing. We use a lot of language around that as they're younger and in everyday life, and they find it quite difficult sometimes to recognize the differences between the functions of the incisors, canines, and molars. I also see confusion sometimes between canines and incisors, particularly I think the position in the mouth. A lot of the time children think that canines are just the pointy versions of incisors. I've heard, said back to me in the classroom before. And at this stage, it's really important to remember that children are still very much moving from that concrete to more abstract reasoning. So they need those practical experiences to make those functions really, really clear. So to tackle this and to, keep the inquiry feeling alive and at the heart of what we're doing, I really bring it back to evidence as much as possible for them. So, for example, I might give them, like lots of us have said, I'll bring real food examples in there. So, it might be carrot sticks, slices of apple, a piece of bread, and then ask as they're, actually making these models, which teeth would be best for biting or tearing or grinding this food. And then another way that I've also thought as well is to compare human teeth with those of herbivores and carnivores and ask what the shape tells us about the diet. So very similar to Paul. Never thought of actually getting them to have pictures of their pets' teeth. That is something that I will use myself moving forward. That's great. But, comparing the differences between teeth as well. And I think by really grounding the learning in that observation and structuring it around questioning, the misconceptions often get challenged quite naturally, and from there they can explain not just which tooth is which, but why they have those different functions as well.
And over to Brenda, we're going to talk oral hygiene very quickly. These oral hygiene links can drift into PSHE mode sometimes, and just wonder if you've got any advice for science-rich investigations that really still keep that focus on inquiry.
Yeah, I mean, it can drift into PSHE, which is, not necessarily a bad thing, but I think it's a perfect opportunity to focus on, again, the discipline of science. So it's not just about discussing those personal experiences or giving advice and guidelines. It's about rooting it in scientific knowledge. And it makes me think of the history of science and perhaps Aristotle, who we accepted his theories for thousands of years. And then the scientific method came along. And there's that real difference between having those ideas about things and about the world around us and wondering about things, but then bringing in the scientific method and that discipline of science. And I think in year 4, it's as simple as starting with a clear question, a testable hypotheses, for example. So you might say, do different drinks affect teeth in different ways? So in year 4 is about the time where we really start talking about variables without necessarily using the term variables, and thinking about what are we going to keep the same? What are we going to change? And as you start doing that, you're moving away from the PSHE realm, if you like. Both complement each other, and coherence across the curriculum subjects is a really powerful thing to be aware of and to exploit, if you like. But we want children to be able to predict, gather data, compare results, that sort of thing. So I think to draw from that, we really want them to be not just young people who are having these experiences and trying to make sense of them. We want them to be active participants in actual scientific inquiry. So they're going to be, again, forming those questions, testing them, using evidence to reach conclusions as well. And that's what makes it science. Children really get to, we tell them things, this is A and this is B, but we want them to gather that evidence for themselves. And that's what they do if we get it right. So, yeah.
Thank you. And sort of connected to that, I'm wondering, when you run those inquiries and those kinds of tests and you want them to be really active with it, do you go sort of full fair test with the children and really let them handle all the controls and variables? Or do you streamline it with your teacher prep, basically, to keep it manageable? Kind of how do you strike that balance?
I'm just wondering whether to answer that question from like a secondary perspective or a primary perspective. So having had experience across the board, I would say that even at GCSE and A level, it's not always the case that you would hand over an investigation to the student for them to work their way through completely. Coursework, the old style coursework, you had a bit more of that, but even within that, there was a lot of support given. So certainly at primary, I know that in the national curriculum, it says that we want children to be able to plan and carry out investigations. But to me, and this might be controversial, I don't think of that as them having to do that from scratch. I think of that as looking at different parts of scientific inquiry and taking responsibility for it. So in year 4, I wouldn't necessarily hand over every part of the investigation. I think that the rigor that you can get is perhaps zooming in on the thinking, discussing what drinks to test and why, and getting all sorts of, ideas about that. But then, bringing it back, getting children to make those predictions based on what they know in terms of the science that we've taught them. And I think in this sort of comparative test, really focusing on what needs to be kept the same to have that controlled experiment. And that's where you can really drill down on the rigor. So the rest of the investigation obviously still matters, but it can be supported with scaffolds and demos, and teacher prep can really focus on some of those aspects, so it's still manageable. But again, as we all know, you have to make these decisions about what part of the scientific method you might focus on in a lesson, because generally we have an hour. You might top and tail that with some routines and et cetera, et cetera. So you've got to make the best use of the time that you've got. So coverage in terms of scientific inquiry doesn't all have to happen in one lesson. It can be across, a half term, across a unit, et cetera, et cetera. So lots of flexibility in the way that we do it, but still making sure that we do get that rigor.
Okay, we looked at senses sparking those first wow moments in year 1, and skeletons and muscles giving the children their insights to their own bodies in year 3, and then that slightly more gritty world of the teeth in year 4. And, the children really do go on quite an adventure throughout their primary years when it comes to the human frame. I'd now just love it if we could zoom out a little bit and just look at almost the big hitters when it comes to practicals, those universal, tried and tested strategies or activities or investigations that work in any year group. I mean, idealistically, every single time for anything senses, skeletons, muscles, or teeth related. So, Paul, if we could start with you. You're very famous for cutting straight to the good stuff. What's your go-to bones and muscles activity that just always lands with the kids every time?
I think it'd be anything that gets children to investigate their own bodies, their own bones, muscles. So it could be like lifting games, pushing, pulling activities, anything where they're investigating, how their own bodies move, the muscles that make them move. It could be lifting things up. It could be tug of war games, jumping, running, sitting or standing, doing a cartwheel, and getting the children to really talk through what it feels like, what they can see with other people, how their joints are moving, and talking about what's making them move.
That's a proper classic there. Nothing beats investigating their own bodies. And I just wonder, when you run those kinds of activities, do you really keep it very open? or let them reflect on what they notice first, or do you build in structure from the beginning, like recording their joint movements, mapping the muscles used as you go?
So a mixture, as with most things. I would start giving them loads of freedom. So maybe small groups, exploring how their bodies are moving, maybe making up condition games to isolate certain muscle groups. So they might be playing football sitting on chairs, or they might play tennis kneeling down. So it's just isolating, which makes it a bit easier for them to then see what's happening. It could just be, even just rolling a ball or throwing and catching a ball to each other. And then we focus in on, from there, we focus in on specific movements and the joints that are used. Quite often we'll do some filming in slow motion, get the iPads out and do some slow motion filming, and then have a look at that back in class. And then, as you say, then map that. And if we've still got, the models that they've made, we'll then try and map that onto those models they made to see that movement. And then, as I suppose, the final bit is bringing it, back to just getting the children then to simulate in class again, what does that muscle movement look like that led them to be able to do that activity.
Okay. Yeah, I see it. The scaffolded approach sort of appears now. Okay. And I bet they enjoy playing sitting down football and tennis on your knees. That sounds fun too. Okay, over to Sarah. Do you have maybe one strategy that you'd recommend to just bring the senses to life?
Yeah, I think for me, senses absolutely have to be taught through hands-on practical work. Children connect with it straight away, and it's just one of those areas that science really comes alive for them. There are so many, simple but really powerful ways to do this as well. It might be taste tests, where they try different flavors with and without their noses pinched, or sound walks where they're listening to and mapping what they can hear around them. Touch activities like the one I explained earlier. I think, again, something that I've been really, really keen on implementing is having experiences that are rooted in real life experiences as well. Discussing with children the food that they eat, the sounds around their school, and, the feel of their jumper or coat, making science feel completely accessible and something that they can connect with as well. And for me, it's just every time that you do one of these activities, it naturally opens doors to questions. We all know that children ask millions of questions within a day, but they seem to really connect with the senses in a way. So it might start with, what can you smell? Which smell is stronger? What can you hear outside? Or, does food taste the same when you hold your nose? But all the different questions that they come up with take children from just noticing their senses to starting to investigate them. And for me, that's really what we want for young scientists.
Okay, great. Thank you very much. And over to Brenda. What's maybe one hands-on activity that you've seen that makes senses, skeletons, or muscles, including teeth as well, instantly click with the kids?
Yes, it's got to be the chicken wing. It's got to be the chicken wing dissection. So it has to be approached sensitively, because you have a real range of children in the class. You might have some that want to name the chicken wing, to children who are a bit squeamish. So that's something to consider. But when it works really well, you get a chicken wing, or you can use a turkey wing, because it's comparatively really big and visual. I like demos to be as big as possible. And you peel back the skin and you can gently pull on a tendon. And for some children, of course, this is something, as Sarah was saying, they might eat daily. It's something they're very familiar with, but they've obviously not known the names of the different parts, and they've probably not tugged on a tendon of a chicken wing either. So it's great when you get to be that kind of vehicle for them to look at the world a little bit differently and a lot more intentionally. So you can actually see the wingtip move when you pull on the tendon. So it's a really nice visual for how the biomechanics of an animal's body, including our bodies, work really. So, and again, it's really nice to show children, to clear up the misconception about the pushing and pulling, that muscles won't be pushing, that you're pulling, and the tendons are those rope-like structures that transfer that pull to the bones. So you can see a really nice clear link with living tissue. So it's a demo that takes like a big idea and it makes it really concrete.
Okay. Well, I mean, to be honest, I could really talk about this all day long for hours and hours, but sadly, it is time to start wrapping up. And I would just love it though if you could each finish up with a one-liner of sorts. If teachers remember one principle or mindset when teaching these topics, senses, skeletons, muscles, and teeth, what would it be? So, Paul, could we start with you?
Yeah, I think it's just to remember that every child has their own science lab for studying the human body, their own skeleton, muscle system that they carry about with them, their own set of teeth, their own set of senses. And it's about encouraging them to be really curious. And we heard Sarah mention this earlier about, children being genuinely curious about their own bodies and how they work.
Okay, thank you. And Sarah, what's your advice here?
So I'd very much have to agree with Paul here. I think the key is to help children see their bodies not just as, abstract diagrams, which we may show them sometimes, but as very much living systems that they use and notice every day. So whether it's the feeling of their coat on their skin or the roll of their teeth when they eat, those senses and these things tell them more about the world around them. So my advice would be always start with their own lived experiences in their own bodies and then build that scientific knowledge around that.
Thank you. And Brenda, what are your thoughts on this?
Well, I think I'm glad that Paul went first because I'm also going to agree with what he said. But I'd add as well that I think what really brings this learning to life is showing children that although we all have these parts, we have variation within that. We're not all the same. And that's a beautiful thing. Skeletons, muscles, teeth, and senses, they all vary. And it's not just for differences' sake. It's because we live in different environments and we need those, in a sense, adaptations, which is a big, big idea in order to survive. So that thread of adaptation is really powerful. And I do think it helps children to see their own bodies as part, like connecting it to that much bigger story of how life works.
Okay, thank you very much. And I just want to say, genuinely, a huge, huge thank you to you guys, Paul, Sarah, and Brenda. Not just for giving us your time, but for really pouring in the kinds of examples that we as teachers can just take straight back into the classroom, use it. I feel like a lot of the things we've spoken about today can be used, within the next few days if you have these lessons coming up. And, in all honesty, it's shows like this and conversations like this only really work because we get brilliant guests like you who are so willing to share these practical ideas. So really, thank you very much.
Thank you so much for having me. And it's been fantastic to meet everybody.
Yeah, I'd agree. It's been amazing chatting with you all. I've genuinely really, really, really enjoyed this.
And I've learnt lots as well.
Yeah, I've got a few pages of notes here as well. So yeah, no, thanks very much.
Absolute pleasure. So as always, everybody, if you've got suggestions for improving the show, topics you'd love us to explore, please do leave a comment or get in touch. So until next time, everyone, thank you for listening and bye for now.